Inverse variation. For inverse variation, the product of pairs of numbers is constant. So to solve for k, just multiply xy. Or if any other variable are used, multiply the two variables. Next is, for the relations of variables, independent variable increases, dependent variable decreases, or vice versa. And for the graph, it is represented by a curved line decreasing to the right, not intersecting the axis. The statement y varies inversely to x translates to y equals k over x, where k is the constant of variation. Example 1, the table shows the number of people who work together, P, and the number of days, D, the task is completed by each group of workers. As we can observe in here, as the number of days increases, the number of people decreases, or vice versa, as the number of people decreases, the number of days increases. The table shows inverse variation because the product of each pair of ordered pair is the same, which is 48. So 8 times 6 is 48, 6 times 8 is 48, 4 times 12, 3 times 16, and 2 times 24 are also 48. So again, in inverse variation, the constant here is the product. Since the constant of variation is 48, therefore the equation is D equals 48 over P. Or we can also write P equals 48 over D. Example number 2. The rate R of a car varies inversely with the time t. On a fixed distance, it is recorded that the speed of the car is 60 kilometers per hour. The time it traveled is 1.5 hours. Find the rate of the car that travels the given distance in 1 hour. So in here, the statement, the rate R of a car varies inversely with the time t, is translated into an equation R equals k over t. And then to solve for k, substitute R equals 60 and t equals 1.5 to the equation. So R is equal to k over t, then 60 equals k over 1.5. Applying cross multiplication, k equals 90 because 60 times 1.5 is 90. And then substitute k equals 90 to the equation, then solve the unknown rate R by substituting the time t, which is 1 hour. So R is equal to k over t. R is equal to 90, which is the constant of variation, and 1 hour, which is the time. And then 90 divided by 1 is 90. And then write the unit of measurement. So the rate is equal to 90 km per hour. Alternative solution to solve problems involving inverse variation, use the formula x sub 1 times y sub 1 is equal to x sub 2 times y sub 2. Okay, let's try the example 2 using the alternative solution. So r sub 1 times t sub 1 is equal to r sub 2 times t sub 2. Replacing the given, r sub 1 is 60, t sub 1 is 1.5, r sub 2 is missing, t sub 2 is 1. 60 times 1.5 is 90, r sub 2 times 1 is r sub 2, so the answer is 90 kilometers per hour, which is the same a while ago in our computation. Let's have additional example. Express the following statement as a mathematical equation. The amount of travel time is inversely proportional to the speed of the car. Okay, the answer is T equals K over S. Next, Express the following statement as a mathematical equation. A varies inversely as the cube of g. Now, the answer is A equals K over G cubed. Number 3, if x varies inversely as the square of y and x equals 9 when y equals 2, what is the equation? So in this example, if we're going to translate x varies inversely as the square of y, that will be x equals k over y squared. And if we want to compute for k by applying cross multiplication, so k is equal to x times y squared is xy squared. So substitute x equals 9 when y equals 2 to solve for k. Therefore, we will have k equals x is 9 and then yung y ay 2, lagyan ng squared. 2 squared is 4 times 9 is 36. So, going back with the equation, replace k by 36. So, the answer will be x is equal to 36 over y squared. Number 4, Boyle's law states that if the temperature stays the same, the pressure of the gas is inversely proportional to the volume. If a cylinder in a steam engine has a pressure of 1000 kilopascals when the volume is 1.8 cubic meters, find the pressure when the volume increases to 3 cubic meters. So in here, if we're going to translate the equation, the pressure of the gas is inversely proportional to the volume. So, P is equal to K over V. Applying cross multiplication, 1 times K is K equals P times V is PV. So, that will be the formula to solve for K. So, the K is equal to PV. K is equal to 1000 kilopascals for the pressure and V is 1.8 cubic meters. So multiplying these two, we will get 1,800. Replace K in the formula or in the equation. P is equal to 1,800 over V. And then replace V with 3 cubic meters to solve for the pressure. So, P is equal to 1,800 over 3. Therefore, 1,800 divided by 3 is equal to 600. 600 kilopascals. Let us solve this problem using the alternative solution. P sub 1 times V sub 1 is equal to P sub 2 times V sub 2. So, a pressure of 1,000 kilopascals when the volume is 1.8 cubic meters, that will be the P sub 1 and V sub 1. So, 100 or 1,000 rather times 1.8 is equal to find the pressure when the volume increases to 3 cubic meters. So, P sub 2 is unknown. And then the new volume is 3. So 1,000 times 1.8 is 1,800 equals P sub 2 times 3 is 3 P sub 2. Divide both sides by 3. So 1,800 divided by 3 is 600 equals 3 P sub 2 over 3. Cancel yung 3. So P sub 2 na lang. So therefore, the final answer is 600. Final answer is 600 kilopascals.